Welcome to Manifested Publishers.
Hello learners, welcome to Manifested Online Lessons. We are learning chemistry from 1 and the topic is still simple classification of substances. The subtopic is separation of solid, liquid mixtures. Maybe to remind you what we discussed in our last lesson, we were discussing the separation of solid mixtures. And the solid mixture we had was a mixture of sodium chloride and iodine. Where sodium chloride, we said, is a white solid, while iodine is a shiny black solid or shiny black crystals. We say that this mixture can be separated using sublimation method because when you heat this mixture, then iodine changes directly from a solid to a gas. And that is the process we call sublimation. So when it changes directly from a solid to a gas, then sodium chloride does not. And therefore, you'll have already separated the mixture of sodium chloride and iodine. Then again, we see that this iodine vapor cools, or this iodine gas cools to form the shiny black crystals again. And this process, we called it deposition process. Again, we gave examples of substances which are able to undergo sublimation and deposition processes as iodine, and this was sodium chloride, ammonium chloride, solid carbon dioxide, and anhydrous iron 3 chloride. Again, we gave the application of this, and then we said that dry ice is used in cold boxes by ice cream vendors. And there are two advantages of using dry ice over the ordinary ice. And one, we say that dry ice is a better coolant compared to ordinary ice. And second was that dry ice sublimes, leaving no wetness, unlike ordinary ice. And therefore, those were the two advantages of using dry ice over the ordinary ice. I left you with the assignment of writing examples of substances which undergoes sublimation process, and I hope you have done that. In this lesson for today, we are discussing separation of solid, liquid mixtures. And if you remember, when we were looking at types of mixtures, solid-liquid mixture was one of them. And we say that this solid-liquid mixture can further be categorized into soluble solid-liquid mixture and insoluble solid-liquid mixture. Therefore, in our solid liquid mixture, this one is divided further into insoluble and soluble. This is where we give the example of sand and water. And in the solid liquid mixture, we give the example of salt and water. When you put salt in water and stir, you're going to form a solution. Therefore, solids which do not dissolve in liquids, they are called insoluble solids, and sand is an example of those insoluble solids. And those solids which dissolve in liquids are called soluble solids, and salt is one of those examples. Again, other examples of soluble solids include, have sugar, we have potassium nitrate, and many other substances. Therefore, in a soluble solid liquid mixture, when a solid or a solid which dissolves in a liquid is called a solvent, a solute. Solid is called a solute, and this liquid, we call it the solvent. A solid which dissolves into a liquid is called a solute, while the liquid in which the solid dissolves is called the solvent. Therefore, when these two combine, they form a solution. A solute and a solvent, when they combine, they form a solution. And this solution, in this case, it will be a homogeneous solution. It will be a homogeneous solution. And you see that a homogeneous solution is a solution where the solute particles and the solvent particles are uniformly distributed. Solute particles and the solvent particles are uniformly distributed in that solution. So it's a solution where the solute and the solvent particles are uniformly distributed. That's what you say, or that is what you call a homogeneous solution. And a mixture of salt and water, when you put salt in water and stir, then you are going to get a solution. And that is now an example of what we are calling a homogeneous solution. Therefore, we have said that solid liquid mixture can be categorized into insoluble solid liquid mixtures and the soluble solid liquid mixtures. In this lesson, we are going to discuss the separation of solid or separation of insoluble solid liquid mixtures. So separation of solid liquid mixtures. And the example we are going to use is sand and water. Sand and water. When you put sand in water and stir, it's saying that this sand will not dissolve in water even if you stir for a whole day. Therefore, a mixture of sand and water is an example of an insoluble solid liquid mixture. So it's an example of an insoluble solid liquid mixture. And therefore, if you put sand in water and stir, then it's not going to dissolve. And when you leave it for some time, that this sand is going to settle at the bottom. The sand settles at the bottom of the water. It will be like this. This is a beaker. This beaker is having water. There's water inside there. Therefore, we are saying that when you put a solid inside water or in water, then this solid is just going to appear at this position. When you stir, it is just going to be uniformly distributed, or some particles of this sand is just going to be in that water. When you leave it to settle for some time, then this sand again will settle at the bottom. And therefore, we can use the decantation method to separate that mixture. We are discussing the decantation method. And decantation method happens when, if you allow this sand to settle, then you pick another beaker, then you pour the water carefully into another beaker, then you'll be left with sand at this point. And therefore, we will have this. So this is the clean beaker we have. That is the method we are calling decantation. That if you have sand and water, you have put sand in water, you have stirred, and then you have given it around 5 minutes to settle. Then when it has settled, then all the sand has gone back at the bottom. Because sand, again, the density is high, therefore that's why it has gone at the bottom of that beaker. Then the decantation method, we are saying that once it settles at the bottom, you take an empty beaker. I had an empty beaker at the beginning. Then you pour this water carefully. You pour this water carefully into the empty beaker. Then you are going to be left with the sand in the beaker you had previously. And that is the method you are calling decantation method. So this method is not very effective because there is still the water you collect in the second beaker is not very clear. So this water is not clear. So it is not clear because it contains solid particles, because it contains some sand particles. It contains some sand particles, and that's why it is not clear. Therefore, the decantation method is not a very effective method of separating insoluble solid liquid mixtures, because the liquid you get after, it is not usually very clear because it has some small particles which will pass through together with water, and that's why it is not a very effective method of separation. And therefore, that is the decantation method. You can use it to separate insoluble solid liquid mixture, and in this case, a mixture of sand and water. Therefore, that brings us to the end of our lesson. But before we end this lesson, I want us to review what we have just said in this lesson. We are discussing separation of solid liquid mixtures. The solid liquid mixtures, again, we have said there are two categories. We have the insoluble solid liquid mixtures, and we have the soluble solid liquid mixtures. We have give the example that we have sand and water as insoluble solid liquid mixture, and there is salt and water as an example of soluble solid liquid mixture. Then we have said that for the soluble solid liquid mixture, that a solid which dissolves in a liquid, that solid, we call it a solute, and the liquid in which the solid dissolves, we call it a solvent. Therefore, when a solute combines with a solvent, you form a solution. And this solution, in this case, it is a homogeneous solution. And we have said that a homogeneous solution is a solution where solute particles and solvent particles are uniformly distributed. Like in this case. In this case, salt is a solute, then water is a solvent. When they mix together, these ones are going to form a solution. When you mix and stir, you will form a solution. And the solution is going to be a homogeneous solution. Then we are starting with insoluble, or in the discussion or discussing the separation of insoluble solid liquid mixtures and which method you can use to separate insoluble solid liquid mixtures. And our example of an insoluble solid liquid mixture, we have taken it as sand and water. And we have said the first method we are going to use to separate sand and water is decantation method. And I have described decantation, and I have said that if you have water in a beaker, you get some sand, you put it in water and stir, is that sand is not going to dissolve in that water. Sand does not dissolve in water. If you allow it to settle for 5 minutes, then the sand will settle at the bottom. The sand will settle at the bottom. If you allow the mixture to stand for around 5 minutes, then the sand settles at the bottom. And therefore, if you get another beaker, you pour the water carefully into another beaker. Then you will have now separated the sand and the water. But again, we have said that this method is not very effective because the water collected is not clear. It contains suspended sand particles. And therefore, that's why decantation is not a very effective method of separating insoluble solid liquid mixtures. Then I've drawn the diagrams for you to describe that. Therefore, that brings us to the end of our today's lesson. But before we end, I will leave you with this assignment. And the assignment is state one method which can be used to separate a mixture of sand and water. State one method which can be used to separate a mixture of sand and water. In the next lesson, we will be discussing another method we can use to separate a mixture of sand and water. See you in the next lesson.